Christo and team.
Good afternoon, ladies and gentlemen, and my dear budding researchers. Me and my team are proud to present you today with our research, Water Requirement in Amaranthus Cruentus, which is a simple model to assess the water wastage in agricultural plants. So let's get on to it. Next. Water is an invaluable resource, and it is our responsibility to ensure that we have sufficient water for our future generations. It is important to know that only 3% of the total water on earth can be used for human consumption. Shockingly, 1.1 billion people across the globe lack the access of clean drinking water. Next. Now let's see water wastage on daily basis. About 95% of the water that enters our home ends up going down the drain. On average, outer water consumption makes over 30% of the total household water consumption. Agriculture is responsible for using 70% of the world's fresh water, and 60% of it is being wasted due to inefficient irrigation systems and application methods. Next. Now let's see overwatering. Overwatering is simply the act of watering a plant excessively beyond its actual requirements. Waterlogged plants are more prone to diseases and bacterial infections. Overwatering causes root rot and suffocation in plants. Overwatering causes water wastage, which is not only harmful to the environment but can also result in higher water bills. Next. Because of these reasons, water wastage must be controlled. We can reduce water wastage by efficiently using irrigation methods. This can be achieved by finding the plant water requirement of these plants.
Plant water requirement refers to the amount of water needed by the plant to replace the water lost due to evaporation and transpiration. Plant water requirement is very important for the irrigation system. Next. Factors that impact plant water requirement are evaporation, transpiration, plant type, microclimates, and plant density, which refers to the number of plants in a given area. Next. Evapotranspiration. Evapotranspiration is the amount of water which escapes into the atmosphere by the process of soil evaporation and leaf transpiration. Next.
Amaranthus Cruentus is a tall herb that has clusters of dark pink flowers. It grows up to about 2 meters in height. It is often used to cure ulcers, diarrhea, high cholesterol, etc.
We have formulated our problem statement, that is, estimation of reference evapotranspiration in Ernakulam and calculating the plant water requirement in Amaranthus Cruentus to avoid overwatering.
As our approach, we have been using Cropboard 8.0, which is a decision support tool developed by FAO's Land and Water Development Division. Cropboard is used for the calculation of crop water requirement and irrigation requirement based on soil, climate, and crop data. The input data used by Cropboard for reference evapotranspiration are minimum and maximum temperature of a given area, the sunshine hours, the wind speed, humidity, longitude, latitude, and altitude. The FAO Penman Monte method, which is used by Cropboard 8.0 for evapotranspiration, is shown here. Our plant water requirement is evapotranspiration of reference crop multiplied by crop coefficient. Crop coefficient, which is the Kc, is the value that represents the crop's evapotranspiration, which is ETC, to the evapotranspiration of reference crop on the same conditions, which is the ETO. The formula is shown here. Our objectives are collecting the meteorological data of Ernakulam for the month of June, finding the evapotranspiration of Amaranthus Cruentus by using Cropboard 8.0, comparing reference evapotranspiration, which is ETO, of Ernakulam throughout the year 2024, finding the plant water requirement to avoid overwatering.
Next. Our initial process was finding the estimated evapotranspiration of Fort Cochin using Cropboard 8.0 with data obtained from ClimWatt 2.0. Next. The
The information about the evapotranspiration will help the agriculture department and farmers to prepare before drought seasons. It will also help in maintaining the soil's moisture and sustaining the plant's health. It will also help in using water efficiently and avoid water wastage. Next. These were some of the references that we used.
Next. We thank Team GYRA for their guidance and useful advices. We thank our teachers and our mentor Smita Miss for their encouragement and unwavering support. We thank Rajagiri Public School for giving us this wonderful opportunity. Last but not the least, I thank IRCC for giving us this opportunity to showcase our research on front of you today. I would like to end with a quote. The more water you waste, the lesser your life will be on earth. Thank you. Thank you for the question. So we have seen that even if we give some the exact nourishment for these plants, we have seen that it does not grow properly. So for the health and longevity, we need the exact amount of water that needs to be replenished after the evapotranspiration. That is a finding, which is like we need to give an exact amount of water that the plant needs, so that it will reduce the water wastage and the plant health will be better. Thank you. So we have our mentors, Smita Miss, and our teachers in our school helping for our project. We are 7th graders. So we formulated our problem statement on January, and we have used Proport 8.0. So many journalists and scientists are using this for the findings of ETO. So we have started finding the results for the whole year, for finding the ETO of the whole year for 2025. Yeah. So we actually have meetings after class, so we all discuss our findings each day.